which the development is now continuing in the EQ project. What I want to show, besides the methodology that we use to make an exploratory analysis of this cognitive pilot channel, is also the fact in general that what we would like to do is to not only develop technical components or technical systems within the project, but also at the same time try and make even an exploratory business analysis and regulatory analysis of what the consequences of such concepts could be. And the case which I would like to share with you today is this cognitive pilot channel. So what is this? I'll briefly explain what it exactly does in a minute, but in general one could say that the CBC, as we call it, is a promising concept which is meant to enable dynamic spectrum allocation, thereby increasing spectrum flexibility and efficiency. Basically, what the CBC is meant to enable is a situation in which terminals that are able to reconfigure themselves to work on different frequencies or to work with different radio access technologies, to actually find those technologies when they are switched from spectrum frequency to spectrum frequency. Whereas the CBC is a technical component which is being developed, there are different ways to set it up. It's also in the telecommunications ecosystem. It might become a new role, it might become a new function by which other roles in this ecosystem have to pass. And there's different ways in which you can do that. And what we're trying to look at is the different business models that can be used with the CBC and the different revenue sharing models that implies, because these things cost money. If you introduce a new role into an ecosystem, funds must go to it, and there's different ways of doing that. So the way we try to do this is to imagine 4 different ways in which the CBC can be deployed, to deduct from that 9 possible revenue sharing models, and then do an exploratory scoring of these 9 models on 4 variables that we think are crucial. So then, initially, for this initial research, we detain 4 sharing options that might deserve further research. So, what does the CBC do very fast? Imagine a situation in which frequencies change from, on the long term, from 1 month to the next, or on the very short term, from 1 second to the next. And imagine a terminal that is able to switch, to reconfigure itself to be able to work on different frequencies and with different radio access technologies. So in this situation, you have an operator 1 having a GSM network at 1800 megahertz. It's purely fictional. The same operator having a 3G network at 2 gigahertz, and an operator 2 having a Wi-Fi base station, an access point as well, at 2.5 gigahertz. Now imagine that, first of all, operator 1 decides to change its frequency to 1500, for example, because it was able to license that kind of spectrum or use it from another operator. Imagine that operator 1 changes the technology used on 2 gigahertz from UMTS to WiMAX, and imagine that operator 2 goes out of business and sells its access points to operator 3. Now the problem is that the device has no idea what radio access technology is located where anymore. So the CBC is then a radio enabler, is a channel which is always available, to which the different operators periodically, and it's not sure what that period is, communicate what technologies are available on what frequency, and then the device, which always knows where the CBC is located, can ask to the CBC what technology is located where. It gets the information, and then it can choose whatever technology it wants to use for a given service. So that's basically in a nutshell what the CBC is trying to do. So what we've been doing in a first phase, and this is not part of the paper, but this was the first phase of our research, was to define different ways, as I said, in which the CBC could be deployed, and then use a business model matrix comprised of 12 components, 12 business model components, to analyze what the consequences could be on the business model for the CBC for these 3 different types. So you see varying components, such as the way in which the revenues are shared, the way in which the costs are shared, the way in which the user is involved, what it means for the interoperability of the system, for the modularity, and so on. And our theory there is that there needs to be a strategic fit between all these components for a business model to work. So these are the 3 deployment types that we discerned. In a first, very basic type, the operator-based system, is very simple. Every operator that is active has a CBC. It has a cognitive pilot channel deployed, and it uses it to guide terminal users from one RAT to the next. In an intermediary-based system, there is a separate entity, a CPC entity, either deployed by a commercial firm, a CPC incorporated, let's say, or the regulator could take up this role and be a neutral party that is responsible for the communicating of these frequencies and these RATs. In a third system is the most complex. It's hierarchical in the sense that you have the best of both worlds, and you have an intermediary CPC, not pointing directly to the access technologies of the operators, but pointing instead to the CPCs of those operators, who then are able to guide the customer further to the RAT requested. And below you see a very short overview, which is more elaborated in the paper of the primary analysis that we did on those 12 components of the business model. Now, for what we did here, what we did first was to extend the typology to 4 types. Basically because during talks with operators it became clear that the operator model in itself has a very interesting variant, which is the association model, which might have impacts on the business model. The association model basically being the operator, like I said, having a CPC, but also allowing a number of other smaller or complementary operators to broadcast, to advertise their radio access technologies onto that same CPC, so as to create some kind of MVNO system for the advertisement of radio access technologies. So first we extended to these 4, and then we defined our 9 revenue sharing models, basically looking at 2 crucial variables. First of all, who controls the CPC, who actually owns it, whether it is the operator that owns it or the third independent party, or both, like in the middle. And the second variable being who has customer ownership, who has the billing relationship with the end user. Is it the operator of the RAT, like we know it today, or is it the CPC incorporated, who has some kind of spectrum broker function and becomes the contact of the customer with the RAT. So based on that, you can have the 9 types that I have here, with the simplest one in the upper left corner, basically being an operator having a CPC, as you see, and another operator, the user paying to that operator, and then the other operator paying to be on the CPC. And the most complex type, I think, is type 5 in the middle, where you have 2 layers of CPC, so it's a hierarchical model, as I explained, and you have the customer paying, because the red lines are the value flows, the revenue flows, the customer paying both the CPC for some broker functions and the RAT that this user eventually chooses. Of course, I have to say immediately, and I think that you will understand, that these are theoretical types, and that, for example, it is very unlikely that type 5, I mean, it doesn't need much research to conclude that type 5 would be highly unlikely to materialize. But this is theoretically what would be possible if you looked at these 2 variables. Now, we used 2 main types of variables to analyze these revenue sharing models. The first being the balance of control versus revenue, and the second being the value proposition. Now, the first one we can discern 2 sub-variables. The first one is the alignment of the gateway and the core assets. Now, the assumption here, first of all, is that in any ecosystem there are there are essential core assets, and then there are supporting assets. And it's pretty clear that in this phase at least, the RATs, the underlying technologies, the networks, remain the most important asset, remain the core asset. And the CPC is an enabler, but it's not the core asset in itself. Now, our assumptions are that in such a situation, the owners of those core assets, being the operators, would have a lot of difficulty in accepting that a separate entity would get revenues while not really providing core assets. So our assumption here is quite simple, that in cases where independent CPC operators gain revenue from customers, the operators would have a lot of difficulties accepting that. The second sub-variable here is the alignment of value production and core asset ownership, which is related to the first variable. What does that mean? It basically means when you look at the customer relationship, the party that holds the relationship with the client and that guarantees the value of the product towards the client should not be, in our assumption, a different party than the one that holds, again, these core assets. So in other words, operators will have difficulties accepting that while they have the rights, while they provide the service, that it will be a separate CPC entity that will have a billing relationship with the customer,